Hello, welcome to our presentation. My name is Nana Kofi Morgan Sapon, and I'm here with. So this is a presentation on the client server project.
Okay, so in this project, we implemented two languages. That's the C for the server part and the Java for the client part. So for us to be able to interact with the UI very well, we use the Java swing to do our UI. So the first thing we did was import our libraries for the app that we do. Then we created a class, the main class that will have it's kind of like the super class that will have the website information, how we run it. So for that part, it has the message field, the user field, and the client's list area. So the client's list area is just a place that when the server sends a list of the clients, it shows the list of clients that are connected to the server. So for this part, the first thing we did was to set our title, that's the web page, how the windows will be like. We set that title, and our menu bar at this side, which has the files, the game settings, and the colors. So after that part, we started to use a mouse pointer so that if you click on it, it can give you some kind of actions that you want it to do. So for that part, so this part is just to call the tic-tac-toe game that we implemented in another file, which we'll talk about that one later. And a file, a send file that you can use, as a client can use to send files to other clients, and they will be able to download at their site to view and do other stuff with it. So for the other part, we have a portion for emojis. This part is meant for emojis, such that if the client is communicating with other clients, they can send emojis to others to create a lively kind of communication between them. And this part is meant to indicate it's kind of like a test screen that shows the list of clients connected, and the left one will contain the place that the user can test with other people, like the chat area. And this place has the kind of like the background pictures of how the web will be, and the other side will contain the clients that are connected. After that, we made the site visible by making it true, because if you make it for the site to be invisible, and we set the emoji frame that the user can click and interact. Then we connected to the server. So connected to the server, we need two main important information, that's the address and the port number. So we decided to use the local host for this one because we are recording the video, and the port number, which is the 8080. So when the client sends information, the server sends information, the client is supposed to be able to kind of write and get the output of it and send it back, like the information back to the other client, so that it can send it to the other clients that are connected to it. So that's what this pattern is doing. And we decided to check errors in case maybe the message wasn't sent well or the format wasn't working well. It will send a kind of like an error message that will tell us how to debug the work. After that, when the server sends us the list of clients connected to it, the client's part is supposed to kind of like update that part so that we know the number of clients that are connected to it. And this part is meant, the update connection status is meant to tell us whether a client is connected to the server or not. So the moment a client connects and the server is not on, it will show us not connected. But if the client is on, it will show us connected, and it will be appended to the test area to make the user aware that this place you are trying to communicate with, the server is on, so now you can do your information. So when it's red, that means it's not connected. When it's green, it's connected. So this one is just to contain how the updated connection will be like. It will create a kind of like a circle which will have either red or green color. And this part is meant to make the mouse button very interactive. So if I click on send, that means the information will send. And if I type on this side, it's meant to take the user inputs of their username and the text information that they want to have. So for the play tic-tac-toe, that one is just meant for the gaming part, for user interaction in case they are bored and they want to have some kind of fun. And the send area is meant to take the user's information, but when it's sending it, it will send it in terms of the hours that it was sent, the date and the year, and the message content, including the username that the user was trying to do. Then the send file is meant to send a file to the user, the other client. So in case the other client is sending a message to the other, it will send a file to them, and they'll be able to see it at their end. And the error, sending error, so in case the file wasn't sent, there will be an error message that will be sent to the user, and the user can be able to download the file that was sent to them at their end. So for the income, this one is just to check whether a message is coming to a client or a client or not from the server side. It will contain the test area information, the client's list, and the list of arrays that was sent to it. And this side is just meant to take the list of the user information, like how the file will be sent, how it will be retrieved from the server to the other clients. And this side is meant to show the updated list. So if clients 1 connects and clients 2 connects later, it will show all those kind of clients that were connected to it. And this part is where the main code. So the moment I click on run, the code will run. But because of time, we've already run the terminal one already. So we just go straight to the point, demonstration. So if I type my username, let's say Jacinta, and I type my message, hello, how are you? So you can see from the screen that the moment I type how, it's kind of like auto complete my sentence for me, so I don't have to type my user, like the information all over again, like in the full text. It generates it for me. When I do hi, it's kind of generates it for me. So the moment I click on send, because this one is not really connected to the server, that's why it's not showing at this side. But when I click on send, you can realize that the information has been sent at this side, and I can decide to send an emoji to the client. So this is the emoji. So this emoji, we generated it using a code. We didn't manually inputted them. We'll talk about that one later. And this one too can send a message, an emoji to the other side. And you can see that the emoji has been connected to this side. So in case I want to play the tic-tac-toe, so in case I want to play a game like the tic-tac, I just have to say that no, and it will come. So just play your game, then you can be able to interact with this. But right now I want to close everything, then I'll go back to this server part. So for the server part, we implemented a lot of OS ideas, just as we did for the clients. So for this side, even though we implemented multi-threading in the clients part, we implemented some threading too in the server part. So the server part, the kind of topics in OS that we implemented, we did the file system, the threading, multi-threading, error handling, concurrency, and many more. We did a lot of things, like 10 topics from file system. So for this time, we decided to use the struct to contain the client's information that we'll be getting from the other client. So it will contain the socket information, the username that the user inputted, just like the demonstration that I showed, and the IP address and the port number. So after that, we created the structs for the file that will be sent. So when the file is being sent, we have to know the sender who is sending it, the receiver's name, and the file name that is being sent, and the time that it was being sent. So this node is meant to keep track of this node part is meant to keep track of all the connected clients that were done. So we decided to use linked list so that we can dynamically update our list as another client is kind of adding to it. So this part is meant to call the struct information that we call. So the moment a client connects to it, we append them to a new node, kind of like a data that we have. So it will append the clients that came, their head, and it will just add them up to the other ones, like kind of like a head. Like you'll be continuously adding those kind of information. And the other parts, we have the create file storage folder. So we decided to implement a file system using the Linux command line. As you can see, we did the mkdir. So that one is kind of a terminal that helps you to create a folder. So we decided to create it using so the moment I run the code, it manually generates it because we are coding in Ubuntu, that's Linux. So this part is meant to send the client list. So after appending all those clients that are connected in the linked list, after that it will send all those kind of clients to the server in the form of the clients that were connected and the number of clients by concatenating their username and the information that came, and send all of them to the client at this side, which is this side. So when it's sent, it will make sure that it's sending all the information to them, excluding the client that it was testing. So for handling clients, so this part of the code is meant to tackle all the information about sending file, messages, and the rest. So this part is meant to make sure that the user input their name inside the text box, because we want to be able to know which client sent the information. And this part is meant to check whether to get the client's address and their port number. And this after that, we use a string copy to add up, like copy the username and the IP address that we got inside the client info structs that we did in the previous one, and their port number, so that we can save those information. After that, we added all those information, the current information we got about that client, to the list that we have, like a long list. Then we print for us to see the username, the IP address, and the port number of that client that are connected to it. And after that, we look through to see whether there's an error and whether the message that the user is sending is the correct one or not, and the size that the user is trying to send. And another portion check whether the information that was sent was a file or a text message. So when it's kind of like sees that this thing is a file, it's kind of extracts the information from it, and it will send it to the allocated client that is needed for it. After that, it will add it up to the folder that we created using the mkdir. Then it will append it, so in case a client wants to get back to get all the information that is acquired later on, it can do that. So we implemented memory allocations because we are dealing with the storage information, that's saving files and those things. There will be a situation that if we don't take care of how we allocate our memory, there can be segmentation faults. So we dynamically allocate our memory so that as we delete information, as we add information, there will be kind of like we'll be tracking those kind of memory address space to prevent further issues with our memory address. And we store those information inside the folder that we created. That's the file storage. Then we free the memory after allocating that kind of specific, so that we can use it for other things. Then all those messages will be broadcasted to all the other clients that are connected to it, so that information can be sent concurrently between them. So the information, from this thing, we realize that the message, I can send the message concurrently to other ones. I don't have to wait for I don't have to type a message A before I can type message B. I'm able to type all the messages at the same time. That's the use of threading. So we use it to achieve our concurrency stage and the rest of the work. And for us to be able to make sure that our computers can communicate in different places, we use the in address any. The in address means that any address that is connected to the local host will be able to communicate with the server. So if I change the local host address to my IP address, my PC will be able to communicate with the server computer, and my PC will behave as the client. So after that, so in socket programming, after giving your address, making sure that any address can communicate with, we have to bind to the socket address so that the kind of like communication be established. Then we listen for incoming communication, which was done at this side. Then we display the port information that was done. Then we accepted the information. Then we close the sockets to prevent any other issues. So if there's a kind of like a failure, or maybe a client's information that was sent couldn't be accepted, then the message will be printed to it. So from this, you realize that we implemented memory allocation, that's freeing the address, the memory space that we use by dynamically allocating and deallocating it. We implemented file system to store information that was sent from the clients to other clients. We implemented multi-threading such that the information that are being sent will be carried on concurrently. So one can send information to other without interfering with the other person's information.